How did Hilbert space become a first in quantum science discovery? Imagine trying to understand the tiniest particles in the universe. How do scientists describe something so small that it behaves in strange ways? That's where Hilbert space comes in. It might sound complex, but it was a game changer in how we understand matter and energy at the quantum level. Back in the early 1900s, classical physics couldn't explain some experiments, like blackbody radiation or the photoelectric effect. These results showed that energy is not continuous but comes in tiny packets called quanta. Scientists needed a new way to describe these strange phenomena. David Hilbert, a mathematician, had developed a special kind of space called Hilbert space. These spaces are infinite dimensional, meaning they can describe an endless number of possibilities. They also have an inner product, which helps measure angles and lengths just like in regular geometry. This was a big step because it allowed mathematicians to work with functions and operators in a precise way. In the late 1920s, John von Neumann took these ideas and applied them to quantum physics. He showed that quantum states could be represented as vectors in a Hilbert space. Think of each state as a point in this space. Observables, like position or momentum, became operators acting on these vectors. This made the math of quantum mechanics much clearer and more consistent. This formalism unified to earlier approaches to quantum physics. Werner Heisenberg's matrix mechanics and Erwin Schrödinger's wave mechanics both fit into the Hilbert space framework. This was a major step because it showed that different ways of describing quantum systems were actually part of the same mathematical structure. Hilbert space also helped develop new tools like operator algebras, which analyze symmetries and measurements in quantum systems. Today, it underpins many areas like quantum computing and quantum information. It allows us to understand superpositions, entanglement, and how particles behave when combined. So, Hilbert space became a first in quantum science discovery because it provided the rigorous mathematical foundation needed to describe the strange world of quantum matter and energy. It was a key step that shaped modern physics and opened the door to new technologies and theories.